Good morning, everyone. I'm pleased to be here. My name is Rafael, and I'm going to present our work on SIEM rule evasions. So the context of this work is threat detection in enterprise networks. And so adversaries frequently attack and intrude enterprise networks, their main goals being data theft, sabotage, or extortion. And most of the times, prevention might not be possible. So at least we need some timely detection to discover malicious activity before the intruders can actually reach their final goals. So therefore, larger organizations have security operation centers or cybersecurity operation centers, which perform centralized security monitorings. And one of their prime tools is a so-called SIEM system, which stands for Security Information and Event Management. So if you're not familiar with that, they basically collect security-related events from the network. These can be more high-level events, such as alerts from intrusion detection systems, but these can also be more low-level events, such as creations of new processes on hosts or newly created network connections. So despite all advances in the area of anomaly detection and also AI-based detection, expert-written detection rules are still the primary means for threat detection in larger enterprise networks. These expert-written rules are also called misuse detection. Most of you might be familiar with that. And in a real-world context, these systems mostly outperform anomaly detection with respect to true and false alerts. So they usually have less false alerts and even detect more attacks. And a further advantage of these systems is that the alerts are relatively easy to understand, even for non-experts. So if there are maybe security analysts who are not in the business for so long, they can usually just open up the rule and see what exactly it detects. And there is also mostly a description telling exactly what it detects. Apart from that, these rules can also be tuned to the environment. So these are advantages why expert-written rules are still mostly used in enterprise networks. And another trend within the last couple of years is that many organizations are moving to open source SIEM solutions, for example, based on OpenSearch. And with this also comes a trend towards more community-driven and open source detection rules. So there are some projects containing detection rules. For example, Elastic maintains a repository. We have Wazoo, for example. But the most notable project, in my opinion, is called Sigma, which is an open source project, which is also on GitHub. And Sigma has around 3,000 rules at the moment from more than 500 contributors. And what's special about it, it is a generic format. And it allows to write converters, which can then convert these rules to different target SIEM products, such as OpenSearch or Splunk or Wazoo, for example. So we asked ourselves, can adversaries deliberately evade such detection rules? And if I'm asking like that, the obvious answer is yes. So here we have an example Sigma rule. The description of this rule says, detects certain command line parameters often used during reconnaissance activity via web shells. And that's exactly what it does. So this rule is supposed to be applied to process creation events under Windows systems. That means every time a new process is created on a Windows system, Windows can create an event telling us some information about this process creation. For example, its parent image and its command line. And here we have a rule that looks if a newly created process has a common web browser as its parent image. So here we have Apache, Tomcat, or Nginx. And then we look at different command lines that might be suspicious. For example, if out of a browser a web shell is created that does some reconnaissance operation. Looking at this rule specifically, we see that this rule checks for wmic.exe, which is the Windows Management Instrumentation Console. And we have a /node parameter behind that. This command can, for example, be used to enable remote desktop connections on remote machines, which is something that attackers might be interested in. And this rule is very easy to evade, for example, because wmic.exe doesn't really care whether we pass parameters with a slash or with a hyphen. So in this case, we can simply replace the parameter by not slash node, but minus node, and this rule is evaded. So it wouldn't trigger, even though the action that is performed is exactly the same. So we looked a bit more thoroughly into this and analyzed approximately 300 Sigma rules out of the context of process creations with respect to potential evasions, whereby evasion we mean that we can find a command that does exactly the same but does not trigger a rule. And we discovered 5 evasion types that are relatively straightforward. The first one being an insertion. So in some cases, we can simply insert irrelevant characters into a command line, such as quotation marks, that simply do not change the outcome of a command, but maybe signatures within Sigma rules do not trigger anymore. Then we have substitutions, where we can, for example, exchange parameters with alternatives. So here we could replace the -o parameter in a curl command, which is looked for in a signature, by an alternative that is called remote name. Sometimes we can also simply omit parts of command lines. One signature in Sigma looks for cscript.exe, but we can simply leave out the .exe in the end because the binary will still be started on a Windows system. Then we have found some reorderings where we can simply switch parameters, or recodings. For example, in the last line, we can see that we replaced a dotted decimal notation of an IP address with its integer representation. Overall, we found that 38% of Sigma rules could be evaded completely, and another 7% could be partially evaded. By this we mean, for example, if you look at the rule on the right-hand side, that we could evade at least one branch of the rule, but not all of them, because several rules have multiple OR branches. This leads to major detection blind spots in enterprise networks, because even though there might be rules to detect some malicious activity, it might still be very easy for adversaries to evade these rules and not be detected. So we asked ourselves, how can we detect such evasions? And we had a very basic idea, which is we would like to detect events that are similar. 3 minutes? That are similar to one's triggering rules, but do not exactly match them. And we found a method where we used supervised learning to train from rules versus benign events. And this is the most important part here, because usually such methods train from malicious events, and most of the time in enterprise networks we might not have enough malicious events. So we started training from rules, which works quite well and also has the advantage that we can also estimate which rule was evaded. We call this idea adaptive misuse detection and created an implementation that is called AMIDES, the adaptive misuse detection system. It works like this. We train with SIEM signatures, in this case process creation rules versus benign events, and then during operation we input live events into the system and perform then some relatively straightforward feature extraction, which I'm not going into detail right now. Then we perform a binary classification, and if the binary classifier decides that the event is malicious, we can then perform a multi-class classification, which estimates which of the SIEM rules has been evaded. In parallel, we perform conventional rule matching, just to make sure that the machine learning algorithm does not miss any matches. And then we merge these alerts, and for example, in this case, we would find out that a rule has been tried to be evaded. Okay. We evaluated AMIDES in a large enterprise network with more than 50,000 users and 4 weeks of Windows process creation events. And we posed 3 research questions, the first being, how well does AMIDES detect rule evasions? And we found that AMIDES detects 70% of our evasions without any false alerts. We also compared AMIDES to a benchmark approach where we learned from malicious events instead of rules and found that they work equally well at the point of having no false alerts. Then we also evaluated how accurate the rule attribution is and found that in most cases it helps analysts checking these rules a lot in finding which of the SIEM rules has been evaded. The third question is AMIDES suited for real-world operation? And I'm not going into detail here, but the quick answer is yes. AMIDES is by far fast enough for real-world operation, and we also tested what happens if benign training data is tainted with evasions, and we also tested other rule type and events except for the process creation rules that I mentioned earlier. So, quick recap, many organizations rely on misuse detection rules such as Sigma to discover intrusions. And we showed that almost half of the 300 analyzed rules can be evaded quite easily. We introduced the adaptive misuse detection idea and also its implementation, AMIDES, to detect such evasions. And we found that AMIDES is fit for purpose. So if you're interested, please look at our GitHub repository. I'm also very happy that we received the Distinguished Artifact Award. So please take a look, and thank you very much for listening. I'm open to questions.